Okay, welcome back. So, in the last session, we have discussed comparators. So, working of mechanical comparators, electrical comparators, electronic comparator, optical comparators. So, next in the module 2 itself, so the next topic is limits, fits and tolerance. So, before discussing the concepts of limits, fits and tolerance, first let us discuss some basic concepts. So, then we will discuss the concepts of interchangeability, concept of selective assembly, then terminology used in system of limits and tolerance. Okay. First let us discuss some basic concepts. So, let us consider a shaft, say its diameter 50 mm. Consider a shaft of diameter, so 50 mm. Shaft. Consider a shaft of diameter 50 mm. Now, machines are unable to produce the exact dimension. Sometime, so machines may produce, so 49.99 mm or 49.98 mm or sometime 50.01 mm or 50.02 mm or sometime exactly 50 mm. Machines are unable to produce the exact dimension. Sometimes it may produce 49.99 or 49.98 or 50.01 or 50.02 or sometimes exactly 50 mm. And hence, it is difficult to produce the component to exact size. Then what are the reasons? See, we know that every manufacturing process involves three elements. So, the three elements are man, machine and materials. So, every manufacturing process involves these three elements: man, machine and materials. Now, already I told you it is difficult to produce the component exact dimensions. So, due to some limitations, the limitations are the first one. The first limitation, human limitation. The first one, human limitation. Human limitation here, lack of skill, lack of skill, lack of interest. So, lack of skill, lack of interest and lack of experience. Next, coming to machine limitations. So, in machine limitations, we have vibrations of machines, vibrations and tool wear. Next, coming to material limitations. Material limitations. In material limitations, we have defects in metals, materials and variation in density, variations in composition. So, already I told you, so in a manufacturing system, these three elements are involved: man, machine and materials. So, because of some limitations like human limitation, machine limitations and material limitations, it is very difficult to produce component to exact size. Suppose if you are try to produce the component to exact size, then production cost will be increased. Say, okay, here this x-axis, increase of accuracy, and this y-axis, production cost. Okay, here the graph will be like this. Suppose if attempts are made to produce component to exact size, then that means increase of accuracy, the production cost will be increased. and hence some allowable variations of sizes are given. So that is called as tolerance. Say example, okay, here already I told you. So consider a shaft of 50 mm dimension. Consider a shaft of 50 mm dimension. Now I am giving some allowable variations. Say example 0.5. Now the upper limit which is equal to plus 50 plus 50.5. The lower limit 50 minus 0.5, 49.5 mm. Now the shaft will be acceptable. The shaft will be acceptable if the dimension of shaft lies between these two limits. Suppose if the dimension does not lie between these two limits, then the part will not be considered. It will be rejected. So in order to reduce the rejection of components, the dimension of part must be lie between these two limits. So this is the introduction. So in any manufacturing system, we have three elements: man, machine and materials. So because of human limitations, machine limitations and metal limitations, it is very difficult to produce the component to exact size, and then some allowances or tolerances given on the dimensions. So this is the first one. Next, coming to concept of interchangeability. So what do you mean by interchangeability? So consider 100 bolts and 100 nuts. Okay, here it consists of 100 bolts and here it consists of 100 nuts. So it is called lot A and it is called lot B. Consider 100 bolts, it is called lot A, and consider 100 bolts, it is called lot B. Now take any one bolt from lot A randomly. Take any one bolt from lot A randomly, and take any one nut randomly from lot B. Now assemble these two machine elements. Suppose if assemble is successful, then we can say that this manufacturing system is in interchangeability, or it follows interchangeability, or we can say that so we have achieved interchangeability in manufacturing. Suppose assembly is not at all successful, then here interchangeability is not at all follow. So okay, here consider 100 bolts and consider 100 nuts. Take any one component randomly and take here also take any one component randomly. Assemble these two elements. If assemble is successful, then we can say that so we have achieved interchangeability in manufacturing system. So we have two types of interchangeability: universal interchangeability and local interchangeability. What do you mean by universal interchangeability and local interchangeability? The parts which are to be assembled are produced in the same plant or in the industry, then it is called as local interchangeability. Then universal interchangeability means the parts which are to be produced are produced in different manufacturing sources, then it is called as universal interchangeability. Next, we have some conditions in order to achieve interchangeability. Then what is the condition to achieve interchangeability? So already I told you. So okay, here some allowable variations are given on the dimension. Okay, here so 50 mm is the basic size. Okay, here allowable variation plus or minus 0.05. Therefore the upper limit which is equal to 50.5 addition, lower limit which is equal to subtraction means 49.5 mm. So the dimension of component lies between these two limits in order to reduce the rejection. So then only we can able to achieve the interchangeability. So this is the concept of interchangeability. So next one, coming to concept of selective assembly. So what do you mean by selective assembly? So selective assembly is also called as group assembly. Group assembly. Okay, here in this technique, the parts produced by machines are classified or grouped based on their sizes. So in this technique, the parts produced by machines are grouped based on their sizes. Say here, this diagram shows the size distribution of holes. Okay, size distribution of holes. Okay, here this is the number of holes. Similarly, we can write the size distribution of shaft. This is the normal distribution. So I am writing the size distribution of shaft. Okay, here number of shafts, size distribution. So this is S1, S2, S3, S4, S5, S6. Okay, here the diagram shows the size distribution of holes and shafts. Now, okay, here the holes of particular size are grouped into H1, H2, H3. H1 consists of particular size of holes, and H2 consists of here also particular size of holes. Similarly, the shafts of particular sizes are grouped into S1, S2, S3, S4, S5, S6 like this. Now, the holes in H1 are to be assembled with S1 only. Next, the holes in H2 are to be assembled with S2 only. I cannot assemble the hole in H2 with S1 because here the parts produced by machines are grouped based on their sizes. Next, okay, here the holes in H5 are to be assembled with S5 only. So in selective assembly or group assembly, the parts are classified according to their sizes. Then this technique is necessary when close tolerance and clearances are critical, means when close tolerance is required. This technique is commonly used in aircraft industries, automobile industries. So to obtain close tolerance and clearance. So this is all about selective assembly. So far we have discussed the introduction, concept of interchangeability and selective assembly. So already we have discussed some basic concepts. So consider a shaft. So say example, diameter 50 mm. So the machines are unable to produce exactly 50 mm. So because of human limitations, material limitations and machine limitations. Human limitations like lack of interest, lack of skill, lack of experience. Machine limitations like vibrations, tool wear. Material limitations like density variation, composition variation, defects. Because of these three limitations, it's very difficult to produce component to exact size. And hence tolerance is given on the dimension. So interchangeability, so we have discussed the concept of interchangeability and we have discussed the concept of selective assembly. And in case of interchangeability, okay, here, so take any component, select any component randomly from lot A and select any component randomly from lot B. Then if assembly is successful, then we can say that manufacturing system is under interchangeability, means it follows the concept of interchangeability. In case of selective assembly, so the parts, okay, here in case of selective assembly, okay, here the components are classified based on their sizes. Okay, here this is the size distribution of hole and this is the size distribution of shaft. Now we can easily assemble the components. Same, that means, okay, here the holes in H1 are to be assembled with S1 only, the holes in H2 are to be assembled with S2 only, the holes in H3 are to be assembled with S3 only. So this is the concept of selective assembly. So next we will discuss terminology in the system of limits and fits. Terminology in the system of limits and fits. Okay. So the first one. So what do you mean by shaft and what do you mean by hole? The first terminology is shaft. The all external features of component is called as shaft, and hole, the all internal features of a component is called as hole. So shaft means all external features of a component, external features. Hole means all internal features of a component. Here I have written the hole diagram and shaft diagram. So the next terminology, okay, here the first one, shaft. Next, hole. So the next one, so nominal size, basic size and actual size. So what do you mean by nominal size? Nominal size is the dimension which is mentioned in the drawing. Say example, in the drawing if they mentioned 30 mm diameter shaft, it's called as nominal size. Then basic size. So what do you mean by basic size? Basic size and nominal size are often same, but basic size is the dimension to which limits of variations are specified. So next we are going to discuss. So basic size is the dimension to which limits of variations are specified. Say example, 30 mm, so plus or minus 0.05. Okay, here I have specified the limits of variations, therefore this is the basic size. Next, actual size. Actual size means the dimension which is measured by the measuring instrument is called as actual size. So we have discussed the nominal size, basic size and actual size. Nominal size means the dimension which is mentioned in the drawing. So basic size and nominal size are often same, but the basic size is the dimension to which limits of variations are specified, and actual size is the dimension so which is measured by the measuring instrument. So next, so limits. So what do you mean by limits? The chapter name is limits, fits and tolerance. What do you mean by limit? So the limits are extreme allowable sizes, within which an operator is expected to make a component. See, okay, here limits means so extreme allowable variations. Extreme means it may be maximum or minimum. Say example, okay, here 50 mm, so plus or minus 0.5. Here the maximum limit is 50.5. The minimum limit is 49.5 mm. So this is the upper limit and this is the lower limit. These two are the extreme allowable dimensions or extreme allowable sizes within which an operator is expected to make a component or produce a component. Why? In order to reduce the rejections. Now, the maximum allowable limit, the maximum allowable dimension is called as upper limit. The minimum allowable dimension is called as lower limit. Now in this diagram, okay, here this is the upper limit of hole. So in the diagram, this is the upper limit of hole, and so this is the lower limit of hole. This is the lower limit of hole. And for this shaft, so this is the upper limit of shaft and this is the lower limit of shaft. So limits means the extreme means it may be maximum or minimum allowable sizes within which an operator is expected to make a component. Okay, so the maximum means the maximum allowable dimension is called as upper limit. This is the maximum allowable dimension. This is the minimum allowable dimension is called as lower limit. So this is called limit. Then what do you mean by tolerance? Okay, here tolerance means, so it is the difference between upper limit and lower limit. Okay, it is called as tolerance. So this is tolerance. So this zone is called as tolerance. So tolerance is nothing but the difference between upper limit or lower limit, or allowable variations of size. Allowable variation. This tolerance is allowable variations of size is called as tolerance. Okay, here in case of shaft, this is the shaft tolerance. So this is shaft tolerance, and this is hole tolerance. This is hole tolerance. So allowable variations of size is called as tolerance. Then what do you mean by tolerance zone? This zone is called as tolerance zone. The zone bounded by upper limit and lower limit is called as tolerance zone. So this is called as tolerance zone. Okay, here. So this is called as tolerance zone. So we have discussed what do you mean by tolerance. So tolerance is the difference between the upper limit and lower limit. The difference between the upper limit and lower limit is called as tolerance, or the allowable variation of size is called as tolerance. So why tolerance is given? Already I told you we have, because of 3 limitations, it's very difficult to produce exact size. That's why tolerance is given. Tolerance means the allowable variation of size is called as tolerance, or it's the difference between upper limit and lower limit. Okay, this is called as tolerance zone. Tolerance zone. So next one, okay, here we have one line. So this line is called as zero line. So zero line means the line which corresponds to the basic size of hole or basic size of shaft, basic size. Okay, here 30 plus or minus 0.05, okay, here 30 mm is the basic size. This is the limits of variations. Means, okay, here the line which corresponds to the basic size of shaft or basic size of hole is called as zero line. From the zero line, so okay, here deviations are measured. Then what do you mean by deviations? Okay, here deviation is the difference between limit of line. So limits of line and zero line means basic size. Okay, here this is hole tolerance. So this is hole tolerance. So then what do you mean by deviation? So deviation is the difference between limits of size. It may be upper limit or lower limit, and basic size. So deviation. So difference between limits of size minus basic size. Suppose if limit of size is upper limit, then it's called upper deviation. Suppose if limits of size is lower limit, then it's called as lower deviation. Now, okay, here in the diagram, so this is upper limit and this is the zero line. This zero line represents the basic size. Now this difference, so this difference is called as upper deviation. Difference between the upper limit and basic size. This is the basic size. Okay, here this is the basic size. Zero line nothing but the line which corresponds to the basic size of shaft or hole. So it may be represents the dimension of basic size of shaft or basic size of hole. Now upper deviation means the difference between upper limit of shaft and upper limit and basic size. So now lower deviation, upper deviation, this is the lower deviation, is the difference between lower limit and zero line. This is corresponds to, or this is with respect to hole. Now with respect to shaft. This is the upper limit of shaft and this is the zero line. Therefore, so this is the upper deviation. This is the upper deviation. Then what is the lower deviation here? So lower deviation here, the difference between zero line and lower limit. So this is the lower deviation. This is the lower deviation. Now we have one more terminology, fundamental deviation. Fundamental deviation means the difference between the limit of line which is nearer to the zero line and basic size. Say, okay, here this is the zero line. Now, okay, here we have upper deviation and lower deviation. Then which one is the fundamental deviation? Fundamental deviation means the line which is the difference between the limit of line and zero line. Okay, here out of these two deviation, the lower deviation means the lower limit is closer to the zero line. Therefore, for fundamental deviation for hole which is equal to the difference between lower limit and zero line. This is the fundamental deviation for hole. Fundamental deviation for shaft is given by the, okay, here out of upper deviation and lower, or out of upper limit and lower limit, upper limit is closer to the 0 line. Therefore, the difference between the line or limit, so limit of size which is closer to the 0 line and basic size. Okay, here the fundamental deviation of shaft is nothing but the difference between the upper limit and 0 line. So these are the some terms used in system of limits and fits. So once I will discuss briefly shaft. So shaft nothing but the external features. All external features of component is called as shaft. Hole means all internal features of a component is called as hole. Then we have three sizes: nominal size, basic size and actual size. Nominal size means the dimension which is mentioned in the drawing is called as nominal size. Basic size and nominal size are almost same, but in the basic size is the dimension to which limits of variations are specified. Already I told you, okay, here say example 30 plus or minus, see here 50 plus or minus 0.5, okay, here 50 is the basic size. Then actual size means actual size is the size which is measured by the measuring instrument. Then so limits are extreme allowable variations, extreme allowable variations are sizes within which an operator is expected to make a component is called as limit. The maximum allowable size is called as upper limit, the minimum allowable size is called as lower limit. So and similarly tolerance means the allowable variation of size. Tolerance means allowable variation of size is called as tolerance, or it is the difference between upper limit and lower limit. So this is called as tolerance. So the difference between upper limit and lower limit, this is hole tolerance. The difference between upper limit and lower limit, this is called as shaft tolerance. Then deviation is the difference between the limits of size and basic size. And in the deviation, suppose if the limit of size, suppose so upper deviation means is the difference between upper limit and basic size, and lower limit, so lower deviation means the difference between lower limit and basic size. So this is all about terminologies. Now let us consider one simple example. A shaft of 25 mm basic size is given as 25 plus or minus 0.02 mm. Find the tolerance. Okay, here a shaft of 25 mm basic size. This is the basic size is given as 25 plus or minus 0.02 mm. Then find the tolerance. Okay, here already I told you. So tolerance nothing but upper limit minus lower limit. The given dimension is 25 plus or minus 0.02 mm. So now, so the upper limit is given by so 25 minus plus 2, therefore 25.02 mm. So lower limit is given by so 25 minus 0.02, which is equal to so 24.98 mm. Now the tolerance is given by so difference between upper limit and lower limit. Difference between upper limit and lower limit, that is 25.02 minus 24.98, which is equal to 0.04 mm. So this is the tolerance so given on the shaft. The dimension of shaft lies between 25.02 and 24.98 in order to reduce the rejection of components. Okay, here this can be represented. Okay, here this is the shaft. So this is the upper limit of shaft, and this is the lower limit of shaft, lower limit. This is the upper limit, and this is the tolerance. Tolerance which is equal to 0.04 mm. So upper limit of shaft which is equal to 25.02, lower limit of shaft which is equal to so 24.98 mm. So this is all about the introduction of limits, fits and tolerance.